Hello and welcome to the fifth tutorial about GeNYG and NextJS. So far we saw how to create components, handle pages, creating single page applications, but we didn't touch yet the server-side part, that is mainly APIs and endpoints. So first thing first, we will go with creating some of these APIs. Then we will connect a database system, in our case MongoDB. We create models server-side to handle the connection with our resources inside the collections of MongoDB. And finally, we will connect our front end from the single page application point of view with our backend thanks to the AJAX calls system. The command to create endpoints, it is GeNYG API. This command will actually prompt us to specify the path of our routes and the method. So in our case, we will go with projects because we want to manage the project's resources. And we will start with a get in order to retrieve from the server or from our database the list of all the projects ever made inside Getapper, since we are building the Getapper official website. After invoking this command, we can see now that inside the endpoints, a new folder has been created with some bunches of files inside. Let's start from the interfaces. The interfaces file is just a group of types, mainly. So we have the query string parameters, a success response type, a global endpoint response, and the request. We will see one by one what does it mean. So far, we can say that the query string parameters is the parameters coming from the request itself, specifically from the route. So the query parameter that we can specify with the question mark or some parameter inside the route, like if we have an API, let's say /projects/project ID, and the project ID it's actually, I don't know, 1, 2, 3, or a slug name or anything, that is a parameter. It is included in the query string parameters. The success response, it is the type of the response when there is a success that we will return to the client. The endpoint response is the, let's say, the merge, the union between a successful response or the error response, that is pretty standard. And finally, we have the request type that is used inside the index file handler that we will see really soon. Let's switch really fast now inside the validations file. So, as we already saw in the front-end part, we are using YAP, also from the back-end point of view, to validate the parameters coming from the front-end. This is a really important concept when building a RESTful server, because everything that is coming from the front-end, we cannot trust. Even if we build our form with all the validation, it is perfect, it looks very nice, we cannot rely on what we've been built from in the browser, in the front-end part, because a user can always bypass that and can always trigger API calls to our server without going through our UI, with tools like the curl terminal command or something more advanced like Postman. They can simulate pretty much everything, so we cannot rely on our UI. So we have to, every time, validate our parameters and be sure that they respect our validation. This is achieved with the app, and we will see later how we can do that. Now let's go to the handle file. So this is where the controller and the business logic relies. The handle file receives two objects. These are pretty common when building a Node.js server, a request and a response object. We manage them a little bit with GeNYG, with our library inside this response handle folder. But the important to know is that this request will contain all the parameters that are coming from the browser, from our clients. And the response instead will be the object that we will populate with the response to return to the client itself. So the request object has the same type that we just saw inside the interface. That is, let's say, a union of validations plus the query string parameter, and as we will see later on, also some payload. If the request is not, let's say, a get, but it is like a post or a patch, it can contain also a payload, some parameters that we would need to create or to modify some resources inside our database. Let's say the code for the request follows this script out of the box. So we have the validation result coming from the request that is automatically populated by GeNYG thanks to the validations file that we provided here. And if there is some errors in the validation, then we will return immediately at this bad request status code. Otherwise, we can go on and proceed with our let's say business logic. So here it is the place where we will call our database to retrieve our data and to return to our front end. In case, instead of generic errors that are not catched before, we have this generic error system management with this console error, just to show to developers what is going on in the terminal, and this response to the client with a generic internal error message and the status code internal server error. Now, before going in the details of handling these endpoints, we need something to rely on in terms of data. In our case, we will install MongoDB. That is a database system following the no-relational scheme, so it is something different from what we are used to use in the past with SQL, MySQL technologies. We have a command to install it. It is GeNYG Mongo package pkg MongoDB. This command will actually install all the dependencies, and we need to run it just once. And it will also add some dependencies to the package.json, and it will modify our GeNYG file by setting true the package's MongoDB entry. So now we also have inside our lib folder a MongoDB files. Here we have some specific files that we will use automatically or not really automatically, depends in the following steps, let's say. But this is not really important so far, and probably you will never need to watch and to modify these files. But it is important to understand that all the business logic that GeNYG is handling automatically for us when dealing with MongoDB models and collection, it is handled inside this MongoDB folder inside the lib1. So now that we have everything regarding MongoDB, we can first of all specify what is our MongoDB database name and connection. If you now open the .m.local file, we can see that we already have the MongoUri connection string. This is used internally by the MongoDB library to connect our endpoints, our backend, with the database itself. In this case, locally, we will use this connection string that is pretty much standard. This is also the standard port that MongoDB uses. And of course, in order for this to work, we need to install the MongoDB server on our terminal first. And then we have to specify a MongoDB name. In our case, we will call it Getapper website. And we can copy this name. If you open the test, the connection is pretty much looking the same because we will still using the database locally, but here instead of Getapper website, we will put Getapper website test. So we know for sure that when we will run the test, we will not delete or modify collections and documents inside the real, let's say, not production, but this, let's say the database that we are using locally to test from a user point of view. So now the configuration is done. We can close the two environments and we can restart our GeNYG NextJS project because we modified the environment file, so we need to restart the project itself. And we can introduce the new command to actually create a model with MongoDB. The command is GeNYG model MongoDB, like this. The generator will prompt us for the model name, and we will create a model that is actually the project itself. So in our Getapper website, we have a list of projects that we have been made so far, and we want to list them and store them in our database in order to retrieve and populate our UI. So we will call the model project, and that's pretty much it. So if you now open the models and the servers folder inside, we have our project. We also have the GeNYG model command that usually prompts us to specify where the model will be used, if from the client point of view or the common, so shared between server and client, or the server point of view. In our case, since we are creating a let's say a connection with our database, of course the model that we are creating with MongoDB, it is for the server use. It cannot be otherwise. So it is being created inside the server folder. So we have the project folder with the index file, and this is, let's say, the class that has been created. As you can see, it is already full with different methods. If we just fold the code like this, we can see that we are using the MongoDB library to access some properties from the library itself. We are also accessing this MongoDAO from our library that is really useful to, when we invoke the method in our class, to be connected with our MongoDB instance. And our project class, it is made of two parts. One, it is an interface, this one, the iProject, and then the class itself. Why this, let's say, this replication of data? Well, when we store our data inside MongoDB, our, let's say, object representing, in this case, a specific project will be represented with some, let's say, values. So, for example, we will have an underscore ID for representing the unique ID inside the collection. We have created that is of type date, a version number, and we can also add, of course, every fields that we will need. But when we use actually this instance of the project inside our code, inside our code, then we probably want to modify or to enhance this JSON object, because this is what MongoDB is returning, with an instance full of methods, and probably we can add even more fields. In some cases, especially with the date, usually we modify the date in order to not be a simple JavaScript date object, but in some cases we use Moment. That is a very powerful JavaScript library to handle state. And of course, we need to transform and to modify this created with another type, because Moment, it has its own, let's say, object representation. It's not just a simple JSON object. So we will see that having this difference here, what has been stored inside MongoDB and the real instance that we will use inside our code is really useful. And we have, of course, a constructor, so where we can actually transform the object coming from MongoDB inside the instance of our class. And we have this from interface method that does exactly this step. Starting from an iProject, again, the representation of the data in MongoDB, it will actually create a new class instance. By default, this conversion is quite dumb, let's say, because we are just assigning to the class instance the same properties coming from MongoDB. But first of all, with the class instance, now we can access also all these methods that with a simple JSON object we cannot. And also, as we said before, we can enhance, so adding more fields or modify other fields. We will see how to do this, because it's a really important feature that we allow with this kind of representation. So we have some methods like refresh that is needed when we want to refresh the data in our class instance with the MongoDB collection. And we have all the methods to achieve the CRUD, CRUD operations, the standard one with a database, that are the create, read, update, and delete. So with create, we can actually create a new project inside our database. With get by ID, we can read one single project by its object ID. With patch, we can modify one project by specifying the new fields, the new values for the fields. With delete, we can delete the project, and we get list. We have again the read operation, but this time not a specific project, but a list of projects with already some filters and some sorting put in place. Now, if we go back to our admin panel here in the Getapper dashboard, we will remember that the projects are represented right now just by a name. So we didn't add to the form something like an image or a description or tags, nothing at all so far. So we just have the name. And this is the data that we want to represent first in our collection in MongoDB. So what we will do before starting and before creating any business logic is to populate our interface first and then our class with these properties. So first of all, we will add a name that is a string. And we will also add this name to the project instance, and inside our interface we need to remember to add also this name. So the class instance will also inherit the name from the collection in MongoDB. This is what we need right now. We can also enhance our create, because right now when we create a new project we want it to have the name, of course. So let's specify name as a string inside our create operation, and here we can add name. So created is a standard field there with the new date, so we will remember when we created this document inside the collection. And version is just a standard for MongoDB. It is a version code, a version number. So in case our collection, let's say, structure or interface will change in the future, we can use version numbers to remember when we create a specific document, to keep track if there were, let's say, big differences between structures. So we will keep this feature because it sometimes can be really useful, and it doesn't occupy also anything. It doesn't move a lot in terms of performances. So with the create, we are actually creating a new project, and now we are ready to create the endpoints to actually create our project starting from a name. So again, in the terminal, we will call GeNYG Next API. We will specify projects, post. Here we go. Now we can go inside the endpoints post projects. We can open the interfaces. And now we can see that we have a new type that is the payload. So since we are now creating a post endpoint, we can also have a body, a payload within our request. And this payload will contain the name string. That is the name of the project that we want to create. And now if we open our validations, we can see that here there is an error because we are not specifying all the keys specified in the payload object. So we have to put the name, and we will just validate this as a string with minimum 3 characters. We can put also maximum, and we specify it is a required field. like this. Now we have everything. We don't need any query string parameters, so we can leave this empty, doesn't matter. In the handler file, now we can finally build our business logic. So from our request, we will take validation result, but also our payload. So if something is wrong, this will work. Otherwise, we can actually invoke project.create, create, by specifying the name. Let's import the name from the payload. We can save the new project created here, and we can return it. Now we have an error because the success response doesn't provide a project in response here. So we will need to add something here. But what we will need to add? Well, it is important to understand that when the message, this project object, will travel through the web, it will be serialized. So again, we are converting this object that came from MongoDB collection, has been transformed in a class instance, and now again we want to transform in something that is usable and readable by our client. So in this case, the best practice here it is to create another instance of the project model that we can use also on the client side. So let's put some placeholder here at the moment, and let's create a new model. GeNYG model. This time the command will ask us where we want to create the model, if it is to be used in the client or in the server, or as a common shared package between the two. In our case, it is a client one. The practice here again, it is to put the same resource name used in the server, but with FE for frontend. So we will call this model project FE. And if now we open our models client, we have our project frontend. It follows the same principle of the server. So we have an interface that is the data representing the object coming from the server, but we also have a class instance where we can modify and we can add methods to our singular project instance. So here we can say that what we need is the underscore ID, that since object ID is just to be used in the server, we can represent it as a simple string, and the name of the project. We don't really need the version of the document because that is an information used server side. We also, maybe we need or we don't need the when the project has been created, so we can avoid to add, but we can also do it later. Now we need to add these two also here, and we can save. So this is actually the representation of our project for the front end. Inside our handler now, we can go in the success response, and we can tell our type that the project here will be of type iProject frontend. So in this case, we will specify that what we are sending through the API, through the call, it is a project that is following this interface. Of course, here we need to be careful because we are importing inside our server code, because this interface is imported by our handler that is used in the server side, and models create on the client. So if we will need to import and use in this model client file some libraries that needs to access, I don't know, for example, the DOM of the browser, then this can lead to an error in our server code because we don't have access to the DOM server side. Of course, there is no browser. So in that case, what we can do is to create probably a common interface or another common model between client and server where we can specify this interface project frontend. So we can import this file that it doesn't access any of this library between the two models, the server-side representation and the client one, and we will be safe that no error will be triggered. So now we can go again here inside the interfaces. Here we specified iProject frontend, but in our handler here we have an error because the project, it is an instance of the project class used with MongoDB. Instead, the interface project frontend follows another, let's say, interface, it's another object. So we need a method to actually modify the instance of the class inside an object that we can use to be sent via our API. And we can do this by adding a method to our class. Usually we call this method toClient version, and it returns an iProject frontend. Now we have our method to convert our class instance inside an interface that our frontend can understand, and in the handler here we can use it. Now all the typing is working because we are returning what the success response expects, and everything should work. So we have created our first API connected to MongoDB, and also, let's say, connected to the model that we will use in the front-end part of the code. We can see now that inside our pages, the API folder has been created with the projects. So all the API that we will create with the GeNYG Next API command will have the respective folders inside the API pages. The API folder inside the pages folder. This API folder is a special folder by Next.js that is used to route the APIs. So the function, let's say the endpoints in our web server that are not pages, HTML pages, they are not JavaScript files, but they are calls to the server that should trigger some code and return usually some, let's say, serialized data as a JSON object in our case. This is handled by GeNYG, so we just need to create the endpoint to actually populate the endpoint files. Because here, if you're curious, you want to give a look how it works inside, you can see that we created two endpoints, get and post projects. These are represented by the same route, that is /projects. So we have just projects folder with an index file, and here, depending on the method that arrives to the request, so if it is a get or a post, here there will be get or post. So depending on this, a specific require will be triggered here, and this require will actually import one of these two files, index file inside the folder. And so if it is a get, it will be get projects, this endpoint. If it is a post, it will be post projects. And of course, GeNYG is creating for us the two folders with the names that are the expected ones. So everything works out of the box without having to create folders and naming things. Just by specifying the route and the method, we have all of this automatically managed for us. So now that we have all the backend side working and connected to Mongo, we need to also connect our front-end part. So how we can create these AJAX calls that are being invoked by our single page application with the GeNYG Next AJAX command. The command will first prompt us to specify which single page application we want to create this AJAX call into. Right now we just have the admin dashboard, so we can select it. And now we have to specify the API route. So when creating an AJAX call or an endpoint, the parameters are really similar because the AJAX call should point to a specific API. So we kind of need to specify almost the same parameters. So we can put here projects as route, and we can start with the get or also with the post. It doesn't matter. Let's start with the get. So if we are now open the single page applications, admin dashboard, Redux store, extra actions, APIs folder, we can see that we have a new folder here, the get projects, with inside an index file exporting this API action builder and all this code. It is actually all boilerplate, all stuff that GeNYG will handle for us automatically. What we will need to modify, it is actually this get project params and get projects response data. So these are the parameters that we need to send to our backend if we want to, I don't know, for the get to specify some filtering or some sorting, in case of a post to specify the payload and the body of our request. Instead, the response data, it is actually what the backend and the server is returning to us. So as we saw before, for the post, we had the project in terms of interface project front-end object returned. So this get will actually return an object containing a projects that is an I project front-end array. We still didn't build this inside our endpoints, but we will see it really soon. We can already start to populate all of these things. Let's also create our post, since we already have the code for that in the backend. Projects post, and a new folder here is created, post projects. Now we know that to create a new project we need a name. So inside the params we can specify a name string, and in the response data we will have a project that is an iProject front-end interface. Here we also have to specify what is the body of our request. So we can add a new body field that is an object containing what our server is expecting. So this object here, let's say the type of the interface of this object should be similar to the payload object interface we saw before here. And this is the connection between the two world, client and server, in terms of request. And the success response is the connection between the server and the client during the response time. Now let's go back to our UI, and here we can see that if you open project, we have the list of the projects. Here we can create a new project, specifying a name and save it. So let's recover this code that we saw in the previous tutorial, and let's see how we can add the AJAX call in order to create something in our database. So let's go back to admin dashboard, since new project scene, index file, we have the new project form. Here we have the form that is already expecting a name. So if we open our hook file, we have the submit with the action add the new project data. Here, if you remember, writing something and going to project will actually add the string that we just inputted inside of it. So now, of course, we want to change this logic because we don't want to store the projects list inside the Redux anymore. We want to send it to our backend. So we can comment and then delete this code for good later. And now we can dispatch actions dot post projects. So here inside our actions from Redux, thanks to the AJAX command, we actually created a new extra action that is also included inside our actions object. And this post projects actually contains several actions. Some of them can be invoked, should be invoked from the developer, let's say from us. The others instead will be handled by the Redux Saga, the AJAX Redux Saga itself. Now we will see how. So the one that we should actually directly invoke it is the request. So the request takes an object that will expect a name, and the name, it is the data.name. We can also pass here directly the data object, since usually what we are inputting in the form, it's also the same object, the object that we need to pass to the request. So usually this is a shortcut. Okay. This reset is fine, we can leave this. So now we can test that everything is working by seeing also in the network tab what's going on. Let's see now how it works. So here we have our dashboard. Let's call our first project, test project. We are in the network tab, salva, save. And here the projects API return successful. This is the response string from the server. So we have the project with the underscore ID and the name. If we go inside preview, we can see actually a more detailed description. Let's go now back to our UI. We can open our inspector inside the network tab, and we can put project test. Save. And here we have inside our response the project created on our server with the parameters that we specified we wanted to be returned. So the underscore ID, that is the unique identifier for this document inside the projects collection, and the name project test. Here in preview, instead, we can see something more navigatable like project, name, and underscore ID. If we can also use a MongoDB client to check for this. I'm using actually Studio 3D. And if we go inside Getapper website projects and we run this query, we can actually see our document created with the underscore ID, name project test, version 1, and created the date that we actually created this project. So the creation part is working perfectly. Now, if we go to Progetti, we expect to have the list of our project. So let's go back here. So we have our get projects API that we need to be used. And so we can go to projects scene index. Here we have the projects list, use projects scene with the selector get projects list. So first of all, whenever we go to the project scene, maybe we want to refresh our projects list. So we can use a use effect for this. We will dispatch actions.getProjects.request. So doing in this way, we will, every time that we land on the page, we will actually retrieve the projects list updated from our database. But now what is returned from the database, we also want to save in our Redux. So let's see, first of all, if the network call is working. So we can refresh the page, projects, response, it is an empty one. So let's go back to our endpoints and let's complete the get projects handler. So here we can say post projects await project dot get list. So by default, get list has a limit of 10 without any filter. So we can say no filter, and as a limit, something really high, like 1000. So basically, almost all the projects will be returned by the call. This is not the best way of handling stuff in this case. Probably we want to create usually some sort of pagination, and already GeNYG allows this for us out of the box thanks to the skip, limit and skip variables here. But right now, just for the purpose of this tutorial, it is fine in this way. And here we can return our projects by mapping our projects like this. We should specify also in the success response what we are doing. So projects, project frontend array. And here it works fine. So our get here is looking good. So if we go back to our UI and we refresh the page, we can see that now this call to projects have been invoked, get API projects. And in the response, we have the projects array with project test. So everything looks fine. Here, of course, nothing it is showing up because we need to match the response from our request with actually our Redux store that is containing the data that we want to display. So now we can go back to the Redux store slices projects in the index file. Here, with the add a new project action that we created in the other tutorial, we will actually adding to the list of projects what we were inputting in the for. Now, of course, we don't need this anymore, so we can leave the reducers empty. And since we want to use as a reducer an action that is not being created here, but is already declared somewhere else, since it is an extra action, our AJAX call, we will use extra reducers option. It works with this builder function. Builder.addCase. Here we have to specify the action, so we can say extra actions get projects.success. As a second parameter, we have the state and the action itself. And now we can modify the state depending on the action, the success action. So state.list equals action.payload.data.projects. As you can see, automatically WebStorm is providing me all these suggestions. Why? Because we already declared get projects response data as projects array of iProject frontend. So thanks to this interface and how GeNYG is working things behind the scenes, here we know that this action that is returning from the get project success as a payload inside with a data that is containing our projects. So again, this data, it is the success response that we saw before in our endpoint. So now all the projects that are coming from the backend are written inside this state list, and if we go back here, automatically this project has been reinvoked with the use effect, and now in the list we can see our project test. If we create a new project, we can say something else. We can save it. We go to projects, use effect, and here it goes. Of course, now everything is written in the database. So if we clean the cache, if we remove, if we open another window in incognito and everything, we will still have this list because this is now saved inside our database. Now let's try to optimize the performance of our website a little bit, because now every time that we are landing on the projects, we are actually called the API to return all the projects list. And this is not, let's say, really amazing, because we know that the projects list will change when we actually create a new one or we actually delete another one, but we don't have the delete option right now. So I think that a good way to improve this is to add another extra reducer here, builder add case extra actions post projects success with state and action. And we can say to our state.list, it can be our current list plus the new project, action payload data project. So this, from a TypeScript point of view, works perfectly because we know that the post project success is returning an interface project frontend, and also this list is an array of iProject frontend. So here we can actually go to the project scene. We can remove this, so we don't trigger every time it. Now if we go back here, we go to create new project. We can do like this, projects. If we switch to the Redux tab, now we can see that projects post success has a difference. It modified our projects list by adding this another one. And if we go to projects, now we can see another one without having to retrigger the projects read anymore. But of course, when we start up the project for the first time, we want to call that in order to update our projects. Now, if I refresh, thanks to Redux persist, I will still have the projects list without having to actually call the API. So this is working fine, but if I open another tab or another browser and I modify the list, this will be out of date. So I want to, every time that I refresh or that I'm opening my dashboard, I want to refresh the projects list, and then I can rely on the actions that I make as create or deleting in order to update it. Of course, I can also put a refresh button that I can manually invoke in order to refresh it on purpose. In order to do this kind of actions that I just want to trigger when at the startup moment, I can use a Redux Saga. Here we can say projects Saga. I can use this one created by default, and I will say hild take every from Redux Saga fx actions dot app startup. So by writing this in Redux Saga language code, I'm specifying that every time there is an app startup, and actually it happens once every time we open our web page, I want to invoke this function here. So here it is the corresponding code for the dispatch inside our hooks in the Redux Saga word that is put actions.getProjects request. So every time that my web page is loading, I will refresh the projects list, and then I will rely on the get, on the creation or the delete of the projects. You can see this behavior here. I refresh the page, and this projects is invoked and triggered, so the projects list is refreshed. Now every time that I create a new project and I save, this is actually the post, it's not the get. If I go to projects, I have the new project created without having to refresh my list. Now we saw that we are saving the new projects list inside our Redux project slice, so we are just using the interface project frontend, but we didn't see how to use the class instance, the project frontend. So let's go to our Redux store, slices, projects, selectors, and here we can see that when we are calling get projects list, we are returning this list. This list is of type iProjects frontend, or actually this is the type that it should be. So if we go to interfaces, here we can see that this is actually correct because our list contains the name, but now we can update this in this way. Now this is much more correct because this is the representation of our projects inside Redux. So the list is just an array of interface of project frontend. So we know that the Redux store should be a serializable object, so inside our slices we just want Boolean, strings, and numbers. But when we are using our data inside our hooks or inside our components, maybe we want and we can use classes to access methods and to do something different with our data. So here, instead of returning this list that is just an array of project frontend interfaces, we can actually create a selector that will return an array of instances of project frontend. And we can do this thanks to the create selector functionality from the Redux.js toolkit. Like this. Create selector, it is a specific functionality of the Redux.js toolkit, and it is a really good tool to store data that is, let's say, that should be memoized. I will not get in the details of it because I can speak for half an hour about it. So if you have doubt or if you want to understand how it works, please refer to the official documentation. The only thing to understand here is that we are actually retrieving the list of projects from our Redux slice, and we are passing it through this function here that is converting them for us inside an array of project frontend. So let's go to the constructor of our project frontend that we actually still need to create, and it will be quite similar to what we have been done in the frontend. Like this. So now we are converting our simple objects, our simple projects object inside the instance of a class, and this can be really useful because here we can add methods, and again we can add new fields, we can modify current fields, Right now, we don't have to do anything like this in this specific case at the moment, but in the future, it's really important to understand this is what we need to do every time. Now, this is working. So let's repeat this passage because it is really important. We can open the models servers projects. So here we started from this I project, that is the representation of the data inside MongoDB. Here we have the instance of the class project, that is, let's say, the class that we are using to manipulate this interface and extending the simple JSON object with methods and also by altering, if needed, some fields. Then we will, when we need to pass some data from the DB to the client, we can use this to-client version that will convert our class instance inside an instance of interface for our client side, that is this object here. And when we need to use this data inside our Redux sagas or inside our React components hooks, then we can use a selector like this to convert this list of interfaces of simple JSON objects stored inside the Redux into some class instances with methods, new fields, and everything we need. So in this case, we have actually 4 different objects, 4 different representations for the same resource, but as we will see in more advanced example, this is really useful to manipulate and have in every time the right idea on what the data is looking and what we can accomplish with that data. Now let's say that we want to add an edit page for our projects. So let's go back to the project scene. Here we have our projects list that now it is an array of projects front end. So every project here is a class, an instance with methods and fields and everything that we can call and invoke. So let's convert this paper into buttons. And here we have one button for each project. And we can wrap this button with a link. So we will need to move this key here, but now we also have a unique identifier. So as key, we can use the project underscore ID. Like this. Now these are pointing to nuovo progetto, but in reality what we really want to do is to link this to modifica or edit progetto. So now every time that we click on this, we will navigate to modifica progetto with the underscore ID of the project that we want to modify. Of course, we don't have this scene yet, so let's create it. GeNYG Next scene, admin dashboard, edit project. Here we go. Now we should add also this route path here. Like this. And here we need also to specify that there is actually a parameter to be considered. Inside our React router paths, we can specify parameters like this. So we can go here to edit project scene, and we can build the UI of our project scene. First of all, we can retrieve our project ID with the use params from React router. Now we can build a second form that will be really similar to the create new project, but instead we will use it to modify the existing project name. So your gnext form we will create inside the admin components folder, edit project form. So we can uncomment these messages that again will be really similar to this one. Like this. Now the main difference will be that we will need to actually dispatch a new action that we still need to create from the endpoints point of view by using the project ID from the route parameters. Now we will create the patch API for our projects, so we need to specify the project ID of the project that we want to modify. We can do this with curly brackets like this. Inside our interfaces, you can see that automatically GeNYG recognize that we are creating a path with a parameter, so it already put for us the project ID string inside the query string parameters. Even if it is not a query parameter, in Next, the parameters inside the route are still considered query string parameters. Now from our payload we will get the name, and from our query string parameters we will get the project ID. So we will check first that the project exists with that underscore ID in our database, and then we will eventually modify it. Here there is an error because getById expects an object ID, instead project ID is declared as a string. So what we want to do is to specify to Next in general that this parameter is actually an object ID. So we can go to interfaces and we can say here that is an object ID, but this is not sufficient because even if you're specifying that this will arrive as an object ID, still in terms of data from the front end we say that object ID are not serializable, so they should be serialized in such a thing like strings. So inside validations we created a specific UP validator that will validate a string as an object ID, and if it is correct it will actually convert that string inside into an object ID object that then we can use. So here instead of UP string we can say UP object ID imported from the MongoDB library, and so this should work fine. Now if we can check if the project exists or not, and if it doesn't exist, we can return an error. In this case, the error will be a not found. Otherwise, we can modify this project by patching it with the new name coming from the payload. So I wait, project.patch, fields, name. And here in the response, we can return the new project as project to client version. Of course, we need to specify the success response as project iProject front end. And here it will work just fine. Perfect. So now we have our endpoint, and we also want to create the respective AJAX version. Again, project ID, patch. Patch projects by project ID, index. Also here we have our project ID that is a string. In this case is correct because this data will need to travel through the internet, so it should be serializable, so it should be a string. And the response data is again a project frontend. We also have actually a payload, so with the parameters within the project ID we will need to specify a name string. Project ID is already used automatically and handled automatically here by Next and by GeNYG, but here we still need to add our body with the name params.name. And now we can use our AJAX inside our edit form. So here handle submit, we can invoke this patch. Let's import it first. Actions.patch projects by project ID request. Here we need to specify the project ID and the name, like this. inside now the edit projects in hook, we can remove this code because we used in the form, and here we can just import our edit project form. Let's check what's going on here. Let's give it a refresh. Project test, modifica progetto with ID. Something that here we can do, it is actually to use the current name to pre-populate our field. So we will go back inside our edit project form, and we can actually put a use effect. So first of all, we will retrieve all the projects list from Redux. Selectors, get projects list. Now we can use a use memo to return from the projects list the specific project that we want to modify. Given a project ID. Like this. So every time that a project ID or the projects list change, this use memo will run, and if the project change, then we will apply the project name to our form with this use effect. So we will put project as a dependencies, and here we can use the reset function from the form here by specifying name project.name. Now if you refresh, now project test, it is correctly imported from here. If you go to progetti, something else, progetti, another one. Now let's try to modify it into another 1, 2, 3, save. Now we can see that our API call actually triggered with API projects and the ID of the project ID. The response looks fine. Let's check the preview. ID the same, of course, the ID on the database is still the same, but the name now it is another 1, 2, and 3. If we go to projects, now the progetti tab, we can see that the name here didn't change, because remember that every time that now we are landing here, we are not calling the get projects list, but if we refresh, we can see now the name updated. But what if we want to update our project without having to refresh the page, so giving that single page application and dynamic experience? Well, we can still use our reducers. So let's go back to Redux store slices projects index. We will add a new case here, patch projects by project ID, and here our list, we need to do something like this. So we can say state.list or empty array, just as a safety. Then we will map it. So we can have our project, and we can say that if project._id it is equal to action.payload prepare params.project ID. So prepare params are actually the parameters that we send to the API during the request operation. Here we are in the success action, so the payload, it is different, is the response from the backend from the server, but we can still access the parameters that we use during the request thanks to GeNYG and how the AJAX call has been managed inside this prepare params object. So if this project ID is equal to the project ID that I wanted to change and I successfully changed, then here instead of returning the same project from the list, I can return the new project. So I can do return action.payload.data.project. Otherwise, I will return the same project from the list. So with this map, I'm actually modifying only the object that I just modified with my form. So now if we go back here, we can just give it a refresh. Project test 2, save, progetti, project test 2. Now we don't need to refresh anymore. Automatically, the project has been changed. Now we can try to test also the 404 error. So if we open this page and we modify manually the last string with something like this, we will now have this error because we are not checking in the reset form that if the project actually contains something and information. So we want to modify first our component, and here we can do something like this. If project, so only if project is something, then let's reset the form with the current value that we want to use. And now if we refresh, we should avoid that issue. Of course, here now there is nothing because in the list we cannot find that project. And if we try to specify a new string and save it, then we will have this 404 error with the message that we specified in the backend. Now to complete our experience, let's add also the delete button so we can actually remove a project from the list if we don't need it anymore. Let's create first the API. The delete projects by project ID, it is similar to the patch one, but it doesn't have a payload. So here we need to remember it is an object ID. The validations also. We can actually copy and paste this part because it's really similar. So we will retrieve the project ID from the query string parameters. We will search for this project. If it doesn't exist, we will return an error. Instead, if it exists, then we will proceed with the deletion project.delete project ID, or project is the same. You can use this. And as a success response, we will put nothing. Maybe we can specify a message. Like this. The delete function will delete from the collection, and that's it. Now let's add also the AJAX call to do that. Inside our edit project scene, now we can add problem stack with the edit project form, and here we can put a button. Like this. Now we have the option here to modify in this delete button. It is not amazing from a UI point of view, but this is not the goal at the moment. And here we can add a non-click on delete project. This will be a use callback. Now we need the same project ID from the params, from the route params. Project ID. Use this patch hook. Delete projects, request project ID. So in this way, we will invoke the delete of our project, and we can also update our Redux reducer. This time, we can change it a little bit. Instead of a map, we can do a filter. So the filter returning true will keep the document. So here we can say that return project.id different from action payload prepare params project ID. So if the two IDs are the same, then we will actually this will return false, so we will exclude this project ID from the list. Otherwise, we will keep it. So in this way, we will just eliminate from the list the project ID that we are actually deleting. Let's refresh. Let's go to projects, project test2, delete. Let's go to the network tab. Here, everything looks fine. So if we go to project now, we will see that the project doesn't exist anymore. And even if we refresh, we can actually see that the project has been deleted from MongoDB. We can have also another confirmation here, something else, another one too. Here we go. Let's delete also this one. And if we go back here and refresh, we can see that has been deleted. Now that we created all these endpoints for all the 4 different CRUD operations, we still have to see the final file inside each of these endpoints. That is the index.test file. The index.test file, it is again created automatically by GeNYG when we create an endpoint, and it is a really useful, let's say, template to start with the unit testing our endpoints. The concept of unit testing, it is a concept that it is quite common in language coding for backend servers, because it will allow us to test if our endpoints are still working as we want them to do, even after refactorings or modifications, because it would be crazy. Imagine to have an application with hundreds of API. Whenever we modify a model or a method or anything that is imported and included in our code, if we still have to test manually with our UI all the hundreds of APIs manually, it would be an incredible amount of costs in terms of human time. So unit testing will help us to test if our endpoints will return what we expect them to do in different situations. So tests that, let's say, are successful and that they return what the API are supposed to. They are just a little part of the testing process. Instead, we will test all the different and possible situations where our endpoints will receive wrong parameters, for example, or they will try to access wrong data without validations to be successful, for example, a lot of different cases. And all these tests should pass. A test is passing when the expected result that we will receive from the endpoint, it is exactly what we specify that we want it to be. So let's start to dig in some code. Here we can start from the test for the get projects. And the test is quite easy from the start. So we have this variable that is just used to declare what is the endpoint that we want to test. We have a before all and an after all calls. These are used by Jest. Jest is the library that we will use to test our APIs, our endpoints. It is a well-common known library to do testing. We can use it also to do some front-end tests, but we still didn't implement it for GeNYG in Next.js. So right now we can just say that we have these keywords that are before all, describe, test, and after all, that as you can see here there is no definition and they are not imported. But when we run this index test file inside the Jest environment, then these functions will be actually, let's say, defined by Jest itself. So they will be found and they will be also executed. So again, before all, it is some code that we want to run before each test, actually before all the tests, and after all, at the end of it. Here you can already see that we have some code here, some template like cleanDB or closedB connection. So this can be, this is the right place, for instance, to clean our test database before running the test, because we want all the unit tests to start and to run every time in the exactly same situations. We don't want previous documents to have been already saved and then reused. No, we want to clear anything before. And in the after all, instead, it's a good place, or if we want to clean again the database, but if we clean it before all every time, then we don't need to do it, or specifically in this case, to close the DB connection. So if you're using MongoDB, for instance, and we open a connection as soon as we try, for instance, to read, so to find a document in a collection, then we also need to close the DB connection. But the most important part is the describe. So we describe here, GeNYG prepares for us, let's say, this group of tests, and the name of each group, it is given from the name of the API and then API. So in this example, get projects API. Inside the describe, we have one or more test functions invocation. Each test has a name, so we can identify it in the final report, as we will see, and a function where we will run the test and the code that we want to test for a specific endpoint or whatever. So here we can uncomment this template code to see how it works. In this specific example, we have this test handler invoking this function. So lambda function, it is a term used specifically in, let's say, also from AWS, when we have a function that when this function receives a specific set of data, then it will always return the same data. So this is more or less the concept of a lambda function. So in this case, we are calling our endpoints lambda for this reason. But when you will see test handler.invoke lambda, we are actually simulating the calling of our API like we did with the AJAX call. It will be exactly the same. And so we will specify what is the path that we are trying to invoke, in this case the get projects endpoint, and we can also specify some parameter, as we will see really soon. In response, this endpoint, of course, will return a payload that is exactly the same object that we are receiving from our browser when we are invoking the API with the AJAX call. And here we are also extrapolating a status code. The status code is that code in HTTP that will tell us immediately if the call has been successful with a 200 or 200 something response, if there has been some issue with the call, so with some 400 errors for, let's say, client-induced errors, or if there is an internal error, so all the family of the 500 and something errors. Another really important keyword from Jest is this expect. So expect is the function that we use to check if a specific variable, object, array, whatever, is actually equal, not equal, greater, different, contains, and a lot of possibilities of something fields. So in this specific template, really easy code, we expect that the status code after this invocation will be okay. So we have these keywords here like to be, but we will see there are a lot more. This is the easiest one because it will just allows us to check if the status code is okay. If it is, the test will go on without any issue. If it is not, it means that there is an error, and then it will raise an error in the final report. It is important here to understand that the fact that the status code here it is okay to be okay doesn't mean specifically that whenever we call this lambda to test for testing, it should be okay. Actually, there will be a lot of tests where this will be wrong. So let's make an example like this. Okay, actually for the get, we don't have really any validations yet. So it is a little bit hard to trigger an error because there is really not something, there is not a lot to test. So for the get, we will just leave this code and we will wait for a result. We can also expect our payload to be, and here we have all the suggestions, as you can see, and we can say payload dot length because payload dot projects dot length to be greater than or equal to 0. So with this piece of code, we are actually testing that the projects variable is present inside the payload. It is an array, so it has a length property, and this length should be greater or equal to 0. So if we didn't create any projects before, it should be 0, otherwise it should contain something. If you are cleaning the DB, actually, before running all the tests, here we know that it should actually be 0, because no projects will be loaded inside the database. So here we can clean our DB, and this function is not defined, but we have some, let's say, code that we already used in other projects that we can copy and paste. And this is what I will do just right now. So I will copy this index file inside this test utils that is already created by GeNYG with some setup test. And here I will just remove some code that we don't need right here. I will just keep the clean DB. And I will call project delete main. Actually, delete main is not defined inside our project, so we can copy and paste our delete, call it delete main and remove the underscore ID, and here we can invoke delete main. We can remove the filter like this. So when we call cleanDB, that now we can import from our test utils, we will just remove everything. So it's really important that we run these files only under test configuration. So this file here will be loaded, the Getapper website test MongoDB name will be used. So we are sure that we will remove all the projects inside our database and its collections precisely defined for testing purposes. Here we can uncomment closeDB connection. It is already defined in the lib MongoDB. So this is actually already existing if you're using Mongo, so we can import from this library. Now we can try to run our tests. So first of all, this code from TypeScript will be transpiled in JavaScript, and then it will be run from Jest. Here we can see that the test suits are 4 because we actually have 4 endpoints. Even if we just now completed this one, the other files are still recognized from Jest. And all the tests actually passed, including the one here where we put some business logic. So we know this is working. And there is here just this console log here. Okay. Perfect. All the tests are passing, and this is working. We didn't do anything strange here. We can put also some console log if we really want to test what are the values of this stuff. But let's move on with the post projects. So here we already have some payload, some validations. It will be much more interesting. So again, we can uncomment cleanDB and closeDB connection. We can uncomment this call and this one. We can import the two functions. And here we have this. Now, if we try to run again the tests, I expect here to be an error. In fact, it is, and exactly in the post projects file. here just warn us that in the post projects API described, that is this one, the test failed precisely because we were expecting status code 200, instead we received 400. This is because we know that the post projects API actually expect a payload to validate with the name of the project, but we are not passing any of this. So this is actually causing an error. But this error actually, we can convert this error in actually a test. So here we can convert this in bad request that has the code 400, and we can put as the name of this specific test, it should return an error cause no payload specified. So now if we try to run again the tests, I expect, even if this invocation was wrong, since we are expecting it to be wrong, the test to pass, and it is like this. Now we can copy this test, give it another name, and try a different one. So here we can add some params. We can specify payload. In the payload, actually here it is a good practice, if we know that we are invoking the Lambda functions expecting an error, it is also a good practice to specify that we are expecting probably an error. So we can write here error response. For a successful response, instead, we can leave success response. So here in the payload, we can put the name, and I will put as a name just 2 characters like this. And I want to write to console log what I'm receiving in return. Let's run the tests again. Now we have this console log with message name must be at least 3 characters. So this is also a perfect test. It is passing because it is a bad request, but we can move one step further and say that payload dot message, and we know it is again an error response. So we don't have actually inside payload, we will not have a project, but we will just have eventually a message. We can copy and paste this. So not only we are saying that this invocation is wrong, but it is wrong because of this reason. Now we can put whatever test we want, like we can put a test with more than 200 characters, so testing also that the name should be less than that. We can put another kind of variable instead of a string and see what happens. But for the purpose here, I think that this is already enough clear how this works. Here we can just specify another message. This is really important to augment the readability of our tests, because name should be at least 3 charts. And here it should return a project successfully created. Project name. Can remove these console logs. So here we are expecting OK, and we are expecting payload to actually, here it is a successful response. So post projects API success response. So here we can access payload dot project dot name to be project name. So we are not only testing that our endpoint is returning 200, so successful status code, but also that the project created in the database has the same name specified from the API. If we try to run again our test, hopefully all of them should pass. It is. Here we can note that the test suits are 4. So remember, we have 1 suit for each describe, and we have 1 describe for each endpoint. And the number of tests instead is the sum of all these tests. So since here we put 3 tests for 1 describe, we have 3 inside this file, other 3 for the other 3 endpoints, so 6 total tests. So here we are checking and everything is working. Our project has been created. Then, of course, we can also test the other endpoints. So with the patch, for example, you can always uncomment this code. And here we can, first of all, create a project. Project.create project name. So here we can use as query string, we know that we can specify a project ID as a string. As payload, we can put name new project name. And here we can expect the project name to be the new one specified. Let's see if it works. Perfect. So it should successfully update the project name. Now we can create a test that is failing for the patch as well. It should return 404 error. And here instead we will pass a new object ID to X string. So here we are just creating a random object ID that of course there will be no project in the database corresponding. Here we can pass this as well, and here we can put not found. And it is working. And we can also put a bad request. For example, starting from the previously working one, we can put like this, project to X string, and here again we can put just 2 characters. And we can expect again to have a validation error. Perfect. Now we can come back inside our get projects, because now we have something more that we can test. So here we can create a project, so we can expect this to return a project's length of 1. We don't need actually this. It should return 1 project. It should return 0 projects. We can also complete the delete one. In this case, the code can be similar to the patch. So we can copy these to create a project. And then we can try to delete project ID to X string. This should be successful. So how we test that this project has been deleted for sure? Well, we can try to retrieve it from the database. So we can say const project to await project get by ID project ID, and we can expect project to be null. It is actually a function for jest. We can run it, and as expected, all the tests are passing. We saw that we can create endpoints that are callable from and invocable from the browser, particular from our single page applications dynamically. But actually we can use also our models, specifically the ones created from the server side. Also when server side rendering our pages, we can also actually use some AJAX call dynamically inside our static pages. So we will see the first type of this. So we saw before that we can have here inside our home page some services like this that corresponds here. If we go to this URL after running the project, we can see that we have these services, and here it was expected to be the list of our projects. So without spending time on the UI, what we can actually do is see how we can use the models created with MongoDB in order to retrieve some data and to use this data inside our static pages. I will create a different page for this purpose. So GeNYG Next page. In the root, we can call this page projects. And we want a static generation props or a server-side rendering props. So we will go with static generation. The projects folder is created with the index file. Perfect. Now we should remember that the get static props function, like the get server-side props, also they contains code that is ran by the server. And after the server ran this code, return these props, then should be serializable and are passed to our components. Actually, these props are also passed inside our HTML page, that's why they should be serializable, but they're also used server-side to generate a first HTML of the page. So when the code is returned to the front end, everything is already in place. And React will also be able to rehydrate these components thanks to this props object. So here we can call actually our models methods. So we can say const projects, await projects, project actually dot get list. Again, we will not filter, we will just specify as a limit, again, 1000 in order to return almost all of them right now, and we can pass this to these props. We should actually say here that these projects props needs to be defined first, so we can specify them as I project frontend. So here now we have an error, and we can fix it as we already did in the endpoint with a map to client version. Perfect. So we already know that this client version contains only string, numbers, arrays, nothing weird, so everything is serializable, and this projects list will be passed to our page. So here I will just create a simple stack, and with the projects, I will map this project, and I will create simple buttons with them. Project name, project ID. Now if we go back here and we navigate the /projects page, we can see that our projects have been retrieved from the database, from our model, and they are displayed here. Now we can also open again the admin page. Inside the projects, we can add a new project here. If we go back here, by refreshing the page, we will see the new project. Here already, again, is already important to understand the difference between static generation, and we know that here we will see every time the most updated projects, because in development mode everything is refreshed on the fly, but in our production environment instead, we know that we can use the revalidate property to refresh the page every seconds. Now we can create new projects, edit, and delete and list them, so we actually have all the CRUD operations, and we can consider also completed this part.